And welcome into percent tax and discount word problems day one, my party people. So in today's class, we are really going to be focusing on, hey, when it comes to taxes and discounts, how can we make sure we know what we're doing in any given word problem? How can we make sure that if I see the word percent discount, that I know whether I'm calculating the discount itself or the final price after the discount? There's a ton of different situations that we want to be prepared to handle. And so let's go ahead here and understand today's game plan. Number one, first we're going to refresh on that percent formula and make sure that we have it down. Because every problem that we do today, every single problem is going to involve that formula. Now, number two, it goes beyond just memorizing the formula. We have to learn how to apply taxes and discounts the right way. And when it comes to the time where we practice the word problems, we're going to be really diving in and making sure that we're combining our basic word problem strategy with the formula so we can really truly breed that confidence that we really want at the end of the day. So let's just go ahead and dive straight into it, starting off with our percent formula. So the percent formula is the percent multiplied by the original equals the result. But there's a main idea that we have to have down written with this formula. And it's going to be this right here. The percent you apply is the result that you get. So allow me to highlight the proper words here. The percent that you apply is the result that you get. So my party people, anybody here who's been to one of my percentage classes before, who here feels like this is echoing through their head, during the class and after class for you personally? All right, so yeah, the chat box is giving their answer there, saying, yep, absolutely. And that's because, remember, main ideas are there to support the formulas that you have. There's no point in memorizing a formula if all you're doing is really just memorizing it. We have to learn how it's going to be used. And it's this right here. The percent and the result, they represent the same thing. One is just in the form of a percent, and the result is in the actual amount. In most cases, that's going to be a dollar amount. So if we say, my party people, and don't worry, you don't have to get this down immediately, but if we say, hey, we're going to be applying a 20% discount, that's what we're plugging in for the percent. If we say that, well, then the result that we get will represent the dollar amount. It could be, let's say that amounts to a $30 discount, but the result that you get represents the discount. So one more time, everybody, before we continue going and get that practice in, remember, the percent, whatever it represents, will also be what your result represents. One is just in a percent form, but the other is in the actual amount. So before we continue, I'll allow you to go ahead and take your notes here. And then when you're done, just let me know that we're ready in the chat box and we'll move forward pretty soon here. So let's go ahead and turn our attention over to a couple of examples here. So this first one here, it says, what is 6% of $82? So let's just go ahead and practice this nice and easy. Everybody, the word of, what does that mean again? In math, the word of tells us to, that's right, it tells us to multiply. So let's go ahead and write that down. We're trying to calculate 6% multiplied by 82. All right. Now, when we are multiplying by a percent, my party people, can we just do it like that? Just 6 times 82 and we're done? Or is there something we have to do with that percentage? That's right. We have to turn that percentage into a decimal. Now, how do we do that again, everybody? We're going to be moving the decimal place over twice to the left. So let's go ahead and zoom on in here. Don't worry. I'll let you go ahead and take a screenshot at the end here. But we are going to convert to a decimal. I'm going to convert 6% to a decimal. And the way that we do that is we're going to move it twice to the left. That is always going to be the case. It's just the shortcut version of dividing by 100. Again, the word percent means out of 100. So to turn it into a decimal, it's dividing by 100, or just to keep it simple, move that decimal place over twice to the left. But as we know, there might be a little bit of a problem, and Jasline's already answering the question in the chat box. I love it. When we have a blank right here, what number belongs in there? Correct. That's going to be a 0. So what we have at the end of the day, my party people, is 0.06 multiplied by 82. And that's where we are. Now, if we're feeling a little anxious or nervous about multiplying with a decimal, don't worry, I got your back, we're good. Here's how we're going to get it done. Let me just make a little more room here with a little vertical line. And let's go ahead and do 82 multiplied by 0.06. So here's step one. When we're multiplying by a decimal, just ignore the decimal. Just ignore the decimal. Ignore it and multiply like normal. So ignore it while you multiply. Let's go ahead and get that going. Because at the end, I'm going to write this here in red. At the end, we're going to bring those decimals back. So bring the decimals back. And again, that's at the end. That's after you multiply. So let's go ahead and do step one. Just ignore those decimals. Just go ahead and multiply, and then we'll see what we have at the end of the fact here. So we have 2 multiplied by 6, and that'll just go ahead and be 12. We'll carry the 1, and we'll leave that right there. And so then next, we have 8 multiplied by 6. 8 multiplied by 6 is 48. Carry the 1, and that'll give us 49. So that was step one. We have ignored the decimal and just multiplied. And then we see that for step two, how many decimal places are we going to bring back, my party people? Correct. That's going to be 2. Because when we take a look at this right here, we have 2 decimal places that we can count on. There's nothing up here. It's just right there. So that's 0. So we have 2 decimal places that we'll bring back. And so that 492 that it looks like the answer is actually going to be, move it back once, move it back twice. It's actually going to be 4.92. And there we are. Nice and easy. So my party people, before I go back and, reflect on the entirety of everything, is it clear here in terms of multiplying by a decimal? Step one, just ignore the decimal. Multiply 82 by 6. That's what we did. We got 492. But then at the end, remember, it's not always going to be 2. It's not always going to be 2. You simply want to count the total number of decimals that you have between the first 2 numbers. So nothing up here, so that counts as nothing. But then here we have 1, 2. So that's what we'll bring back. 1, 2. So 4.92. And that's how we get that final answer. So a couple of things, a couple of notes just to reinforce before we continue is when we turn percentages to decimals, yes, it is always twice to the left. Always. So for converting, it is always twice to the left. Always. Just to make sure I give you that confidence. Always, always, always. And another great question here from Ash saying, hey, so what if this 82 was actually, let's say, 0.82, and we're still multiplying by 0.06? The answer to your question in terms of how many decimals we would actually move back, yeah, you're right. It would be 4. If we had 2 decimal places up here and 2 down here, it would be a total of 4. And so we would go 1, 2, 3, and 4. We would, if that was the case. So great question, because I know somebody else most definitely had that same one for you. So with that said, everybody, are we ready to try another one out? Perhaps on your own. Hey, right on. So let's go ahead and give this next one a shot. I'll give you a chance to try it. And let's work this next one out here. So it says, hey, calculate 15% of 325. So the first thing I'm going to ask is, when we're turning this percent to a decimal, the previous question that we did was a single digit. This one is 2 digits as a percent. My party people, does that change anything in terms of changing the percent to a decimal? Does that change anything at all? Correct. It does not. It does not. We always convert by moving it twice to the left. Always, always, always. So we're going to go ahead and take that 15%. Let me zoom on in a little bit. We're going to take that right there and go 1, 2, right there. So what we have is 0.15 multiplied by 325. And so there we are. So let's write that down right over here and let's go ahead and do the math. So 325 multiplied by 0.15. And to help anybody out who may be feeling a little anxious about multiplying with decimals, don't worry, I got you. We're going to go ahead and first highlight some of these numbers here. So I'm going to highlight the 5 in green to show you the first line that I'm working on that on. And then I'll highlight the second number here, the 1. I'll highlight that in red to, again, show you what we're doing at each turn. So here we go. Let's start off by working on that 5. So first we have 5 multiplied by 5, and that'll give us 25. Don't forget to carry that 2 right there. And so now as we continue, we'll go ahead and have 2 multiplied by 5, which is 10. And when we carry that 2, that's going to be 12. So it's 12, so we carry that 1. Next up, we have 3 multiplied by 5, and that'll be 15. And once we carry the 1, that'll be 16. So in the first line here, we have ourselves 1625. Before I continue, everybody good so far on just working with that 5 that we just did? Right on, right on. Now let's go ahead and move it over to dealing with the 1. Now, just as a reminder, because again, I know somebody's going to need this refresher, so I got your back all the way. So when we move over from this place value to the next one, we have to make sure we start right here. If the 1 is in this second spot, we have to start calculating on this second spot. And that's why you'll see a 0 automatically be placed where it doesn't start at. We have to start here. So we'll put that 0 to show us, hey, we're not going to go there. So cool. Yep. Just wanted to make sure that anybody who made a mistake, and that was the mistake, wanted to make sure that you saw clearly why that was the case. So I got you. Again, this is how confidence is built up. Now, let's go ahead and get to multiplying by 1, because I think we all know how hard multiplying by 1 is. So here we go. 1 multiplied by 5, that's going to be 5. 2 multiplied by 1, that'll be 2. And then 3 multiplied by 1, that'll be 3. And there we are. Let's add everything together as we normally do with the multi-digit multiplication. And here we go. 5 plus 0, that's going to be 5. 2 plus 5, that's going to be 7. 6 plus 2, that's going to be 8. And then 1 plus 3, that's going to be 4. And so there we are, my party people. Are we done? Is the answer 4,875? Yeah, no, it's not. What do we have to do at the end after we multiply with decimals? Exactly, we bring them back. And so with that, let's count. We have over here no decimals here. We have none there. But over here, what do we have? 1, 2. So if we have none up top and 2 on the bottom, that is a total of 2. And so we'll bring back 2 decimal places. 1, 2, and there we are. So the answer here, 15% of 325 ends up being 48.75. If this was money, $48.75. And there we are. Who here is feeling a little more confident in dealing with all these rules that we're throwing your way? Are we feeling a little better about being able to handle that? Good. Good. I am very, very happy. Now, we're not done because I still want to make sure that you feel great. So let's go ahead and try this next one out. Let me put this here on the screen. Here we are. And let's get to work. And let's give this one a shot. Calculate 80% of $110. So here we go. First things first. We can't multiply by that strict percentage. We got to turn it into a decimal, as always. So this one's going to feel a little different. Not because there's anything different going on, but because you might notice that when we move that decimal over twice, 1 and 2, you got a couple of options. You can go ahead and use 0.80. You absolutely can. My party people, what's another way you could write 0.80 that would make your life a little easier? Yeah, we could write it as just not 0.80, but just 0.8. We can use that, absolutely. And I'm going to show you how both calculations give you the same exact answer. Remember, if you have a trailing zero with a decimal, any of those trailing zeros, as long as there's no numbers in between them, you can just remove them. And you can write it as 0.8 if you want to. So with that, no matter what though, you're still always moving it twice. No matter what you see, always moving it twice. And then if you can clean it up somehow like we just did here, sure, go for it. Now let me show you how this will look. So first, let me show you the 110 multiplied by 0.80. Let me show you how this will look first. So here we go. 8 multiplied by 0, okay, that's 0. 1 multiplied by 0, another 0. 1 multiplied by 0, another 0. So it's almost like we didn't need to write that 0 to begin with, but there it is. Then we're going to go ahead and, oh, excuse me, I got too excited there. Let me go ahead and fix that up as 110. I got y'all. Appreciate y'all. Either way, doesn't change the first row, but I appreciate y'all calling that out because I needed that. So here we are going to the second digit here, going to that 8. So we'll have the 0 that we need first, because again, we're dealing with that second place. And now we can begin. We have 0 multiplied by 8, that's 0. 1 multiplied by 8, and that's 8. And then 1 multiplied by 8, that'll be 8 again. Add everything out, nice and easy, and we'll have 0, 0, 8, 8. But again, our answer is not going to be 8,800. We have to bring those decimals back. Exactly. So once we bring those back, we see that we have none up here. And let me use a different color here to keep things consistent. So we have none here. But then over here, we have 1, 2. So we have a total of 2. So we will bring back 2. If we only had 1 total decimal place, we'd only move it 1. If we had 3 total decimals, we'd move back 3. It just depends on what the total count of decimals is up here, always. So in this specific case, it's 2, so we'll bring 2 back. So we'd have 1, 2, and we have 88. And there we go. This is one way of doing it, $88. Now, when we go ahead and try the same exact problem again, just with the 0.8, I know it might feel weird, especially if you're still refreshing. It might feel like, oh, wait, that's going to be a different number, so I shouldn't do that. I know that feeling can be felt by a lot of us, I know. But let me show you that, look, if the math checks out, the math checks out. So look, we'll have 110 again, but this time I did 118 again. I did it again. 110, and then we have 0.8. So let's give it a shot here. 0.8, and let's go. 0 times 8, that's going to be 0. 1 times 8, that's going to be 8. Another 1 times 8 is 8. Everybody, in this circumstance, in this variation, how many decimal places are we bringing back? Yeah, that's just going to be 1. Here, we have none up top, and then we just have 1 on the bottom. So that's going to be a total of 1. And so here we'll go, boom, done, and the answer is 88. Everybody, are these the same answers? Yeah, they absolutely are. Same exact answer. And so hopefully that helps anybody out in terms of if you have a trailing 0, a 0 at the end of a decimal, you can get rid of it. You don't have to use it. And the advantage that gives you, knowing that, is saving time. You don't have to spend the time to write these 3 zeros over here, because if you didn't have those there, boom, you have less lines to work on and you're good. You know and you can trust that you'll get the same answer, but you just have to make sure that you're following the rules. 1, when it comes to turning the percent to a decimal, it is always going to be twice to the left. Again, when you are converting a percent to a decimal, it is always going to be twice to the left. When you're multiplying by decimals, here or here, remember that at the end, you're just bringing back the total number of decimals that you see. It could be 2, it could be 1, it could be 3, it could be 17, who knows? But you don't make assumptions here. You do not make assumptions. You will actually count how many decimals total you have, and you'll bring it back at the end. Notice here we had 2, so we brought back 2. Here we only had 1, so we brought back 1. And that's it. That's the fundamental truth that we have to be able to work with as we move forward into these word problems. But before we continue, everybody, are we feeling good about just that core understanding of dealing with percentages, converting them to decimals, and then multiplying with them? Because if you have that locked down, or even feeling good about it, any sort of good, I promise you that this is going to be a very fun class for you today. Hey, right on. So with that said, let's go ahead now and take it back to our notes, because now we're about to start hitting some word problems. So let's go ahead and bring it back right over here. So there is another fundamental fact that we really have to know. And it's going to sound dumb in terms of how many times I'm going to repeat myself. But if you've been to my classes before, on a regular basis, I will lose my voice repeating myself a million times because I know it'll benefit you. So the question here is, what percent represents the original amount of anything? And that's correct. That is 100%. 100% represents the entirety of anything. You know, the whole Coach Anderson, that's 100% of Coach Anderson. If we're talking about the entire building, that's 100% of the building. If we're talking about, how much this pair of jeans cost, okay, well, the original price is 100% of the price. Before taxes, before discounts, the original thing, the original amount is 100%. Now, why am I repeating myself on this? Well, because let's go ahead and take our notes here for using discounts. And then over here, we'll take our notes for calculating tax. Let's go ahead and begin by taking our notes here with discounts, and then we'll move forward to taxes. I'll give you all the time you need to take these down, and then we're good. So when we're calculating a discount, we want to multiply the original price by the discount percent to find the discount amount. If you're looking at that and you're thinking, what does that mean? Well, I have a pop quiz question for you. My party people, we have the percentage formula, percent times original equals the result. But, big but here, what is that main idea that I also had you write down? Type it out for me, please. Or if you want to just scream it at the top of your lungs without, distracting any family members nearby, go ahead, scream it out. But yes, the percent you apply is the result that you get. So here's how that comes into play. I got you. Right over here, I'm going to highlight this in red. If you're trying to calculate the amount of the discount, you'll multiply by the discount percent. Remember, the percent that you apply and the result that you get on the other side of that formula, they represent the same thing. So if I'm going ahead and say, we have percent times original equals the result. This is one of the biggest lessons that you're going to learn about percent tax and discount, because so many people don't know this. And it's a very, very fundamental truth that makes your life so much easier. So here, if we are talking about this percent here and this result over here, they represent the same idea. So if you're looking for the percent or the discount amount, so how much you're actually saving, you need to put the percent of what you're actually saving. And then on the flip side, let me go ahead and duplicate this to show you the mirror of this. Let me go ahead and grab that, duplicate it, bring it down here. And I'm going to change this to blue. So let me take that out. And let's grab blue over here. And so if we take a look at this second blurb here, so if you're trying to find the final price after a discount, well, guess what? You need to multiply the percent that you have after the discount. So here's what I mean by that. Let me highlight this. So to find the final price after a discount, you need to go ahead and subtract the discount from 100 and multiply by that amount, by that percent. So let me go ahead and break it down and make it real easy for you. Before we get into the examples for it, I gotcha. So my party people, let's go ahead and say we have a 20% discount. And let's just look up here first. Let's suppose that we have a 20% discount. If you are putting that into your formula, this is what you really want to focus on. This is what's going to tell you what this is all about. If you are going to be multiplying by the percentage discount, the result that you get is going to be representing the dollar amount of your discount. That's what I mean by that. Now, everybody, that's probably the easier part. I'm willing to bet that this part down here in blue is the harder part for a lot of us. And I got you. Again, this is what we're here for. So, everybody, quick question, pop quiz. What's the original amount again? What percent represents the entirety? Oh, yeah, that's right. The original percent, the entire thing is 100%. So help me do some pretty easy math, my party people. If the whole thing, if the original is 100% and we had a 20% discount, again, discount means we take it away, right? It means that we're not paying that 20%. So if we do some math here and we take away that discount, my party people, what's left? Oh yeah, y'all flood in the chat box. Yeah, 80%. So what does that 80% represent? This represents the amount that you pay. So this is what you pay. So think about it like this. If you are trying to figure out what your final price is, like what you are going to pay at checkout, this is actually the percent that you want to multiply, because this is the percent that you pay. And so when you apply it, you'll get the amount that you pay. Again, the main idea, the percent that you apply is the result that you get. Is anybody here starting to get the gears going here in terms of what I'm laying out for you? We're still going to practice, don't worry. But I really want to see who understands where I'm going with this here before we start putting it together with those examples. Hey, right on, right on. So keep that in your minds here. Keep that in your minds here. Now let's turn it over to the next page here. And we're going to do the same exact idea, the same premise with taxes. So I'll let you go ahead and take your notes first before I ramble on and talk about how this all works. So feel free, take a moment, write these down, and then we'll move forward momentarily. All right, so let's talk about tax. So when we're calculating a tax, here's the thing. If our goal is to get the amount of the tax, then we want to multiply by the percentage of the tax. Again, it comes down to that main idea. The percent you apply is the result that you get. So if the result that you want, my party people, is the amount of the tax, then you need to multiply that original price by the tax percent. Multiplying by the tax percent gives you the amount of the tax. My party people, yes or no? Does that general idea still ring true? Still feels like that makes sense? Cool, sounds good. And again, we're going to practice this, so I gotcha. But now let me turn your attention over to this one here. So if we are trying to find not the amount of the tax, but if we're trying to find the final price after the tax, everybody help me out again. Discounts, we are taking away, we're subtracting. If we are taxing you, if you're getting taxed, are you adding on to that final price or getting a discount? Yeah, we're adding on, exactly. We're adding on. I wish taxes meant we saved money, but old Uncle Sam doesn't like that too much. So with that said, if we are trying to find that final price after the tax, everybody, we can go ahead and add the tax to the 100% and multiply by the original price. That's one way of doing it. One way. This is not the best way. I'm going to be very real with you. This right here is not the best way. So pay attention to what I'm going to write next to it. Or you can do this. Or you can find the amount of the tax. So find the tax amount, then add it back. Then add it back. I want to go ahead and express that here. Everybody, please take a moment to write that down. So if you're trying to find the final price after the tax, you got two options. One, you can add the tax percent to the 100% and then multiply by that percentage amount, which that's going to give you a typically, it'll give you a 3-digit decimal to work with, which is not fun to multiply by. So the next best option to save time, to make sure that on test day, you are using as little time as possible calculating, you can just go ahead, find the amount of the tax, and then just add it back to the original. Because if you're taxed, let's say $4.50 on a $50 bill, well, cool. You were going to pay $50 for the item, and then just add the $4.50 tax into that, and there you go. You have $54.50. So that's all that means. Just find the tax amount and then add it back if the goal is the final price after the tax. So with that said, my party people, are we ready to dive into some practice? Hey, let's go. I love the excitement. So remember, my party people, we're here to get one day better, one day at a time. So even if we don't get the first one right, or we don't feel perfect in the first one or super confident, I hope that you know that this is an environment that you are able to try risk-free. I don't want you to feel pressure here like this is the actual test. I want you to run your head through a wall with no care in the world. But, and this is a huge, caveat here, you have got to be willing to be honest about the mistakes that you made and learn from them. We're not here to just try one out, see if we're right or wrong, and then move on with our days. No, we are going to spend time understanding why we got it right so we can repeat that success, and why we're wrong so we can avoid that mistake on the actual test. That's what it's always been about. So let's go ahead and turn our attention over to the first example here. So the problem reads, hey, if a pair of shoes is marked at $80 and it's advertised with a 15% discount, what is the amount of the discount? My party people, help me out real quick because that's a lot of words. I'm not a really wordy person. I don't like words. What's the goal of the question? What is the goal of the problem here? That's right. So if you look at the chat box and you're here or seeing a lot of people say RTQ, that means read the question, and that means the question sentence. I know this is all one sentence, but what we're really referring to is the phrasing Who, what, when, where, how many, which of the following. So those question action words, that's where you want to turn your attention to. So this is where the quote question really begins. It says, what is the amount of the discount? Yeah, that's right, Jaslyn. So with that said, my party people, with that said, what are we looking for? Are we looking for the discount amount or the final price after the discount? Which one of these are we looking for? Yeah, we're looking for the discount amount. And I know for some of us, I literally just highlighted it for you. I know, but I really want to make sure that you see how important it is to read the question first. So that's what we want. We want the discount amount. So here's how I'm going to put this, everybody. If you want the discount amount, you want to multiply the original. You want to multiply the original by the percent of the discount. This is what I'm going to consistently and constantly say. We want to multiply by the discount percent if we want the discount amount. Does that make sense, everybody, in terms of how this is going to be set up before I get started? If we want the discount amount, we want to multiply by the discount percent. As long as we follow this rule, the percent you apply is the result you get, we're always going to move in the right direction. So let's try this out, everybody. What was the discount amount that was given to us? Or the discount percent, excuse me. What was the discount percent that was given to us? Yeah, that's going to be 15% right there. So that's the discount percentage that we're given. We don't have to subtract from 100 here. Remember, everybody, if we wanted to subtract from 100%, that means that we're looking for the final price after the discount. And that's not what we're looking for. Here, we just want the amount of the discount. So we'll multiply by the percent of the discount. So that 15% for the discount, that will be moved in terms of its decimal twice to the left to get that decimal value. So boom, boom. And that will be 0.15. My party people, what was that original cost of the pair of shoes? Yeah, that'll be 80. The original price of the shoes was $80. So now that we're here, we can feel confident that because we want to find the discount amount, we'll multiply by the discount percent. And once we do this work here, we can feel very good about whatever number this is being the correct answer. So here we are, my party people. We have 0.15 multiplied by 80. Let's do that here on the side. So we'll have 80 multiplied by 0.15. Let me go ahead and just move this slightly to the left. And here we go. So we have 0 multiplied by 5. That'll be 0. 8 multiplied by 5. That'll be 40. So we'll have 40, and we'll keep it going. So we're going to start off here at the 1, so we'll have to put a 0 here automatically. And here we are. 0 times 1, that'll be 0. And then we have 8 times 1, and that'll be 8. We'll add these together. 0, 0, 4 plus 8 is 12. And we have 1,200. But everybody, remind me again, how many decimals do we have to bring back? And that'll be 2. That's correct. When we count it out here, we have none here. But we have 1, 2 right here. So we'll bring back 2 total. 1, 2, and boom, that gives us $12. And that, my friends, is the amount of the discount. That's what we were looking for. And so we can immediately right there get the answer that we're looking for after setting it up, knowing that the percent that we apply and the result that we get are the same thing, setting things up properly, and we are good. So, my party people, in this problem, again, we do not subtract from anything. No need at all. Because remember, if we were to take this $12, which is the amount of the discount, and we subtracted it from that original 80, what that would give us would end up being $68, but that would be the final price. This problem did not ask us for the final price. We want the amount of the discount, so we just need to apply the percent of the discount, and we're done, and we're all good. But is anybody curious about what that would look like, though, if we were actually trying to find the final price? Is anybody curious about that? Okay, cool. Let's go ahead and give that one a shot, because it's right here. I had it ready. So let's go ahead and look at this slightly altered problem. It reads, hey, look, if a pair of shoes is marked at $80 and it's advertised with a 15% discount, what is the final price after the discount? So everybody, can we confirm that this is a different question? Like, it's the same premise, same numbers, sure, but it's a different question. We're asking for the final price, not the amount of the discount, but the final price after that discount, right? Okay, cool. So we can take the same things that we did here. So let me just copy this over here. Let me just take all this over. Let me copy that, and let's paste it right here. Cool. So everyone, let's take it from where we left off, right? In the previous problem, the same numbers, except it's a different request, a different question. Let's suppose that we went ahead and accidentally just applied the 15% and got the $12. If that's what happened, everybody, what should we do? If that's what happened, what should we do? Right. If we accidentally just use the 15%, no worries. Because what we know right now, everybody, what we know is that this $12 right here, it represents the amount of the discount. So to get that final price, let me just show you right here. Let me just show you that final price. $80, that right there is the original price. If we subtract the $12, which is the amount of the discount, if that is the amount of the discount and we subtract, well, guess what? What we receive down here, it will be the final price. That'll be the final price. And so with that said, everybody, 80 subtract 12, that will give us 68. If we need the visual here, I gotcha. We'll just borrow 1 from the 8. 10 minus 2 is 8. 7 minus 1 will be 6. And there we go. There we go. Our final price is $68. So if you accidentally multiplied by the percentage discount and you really wanted the final price, that's all you would have to do. That's all you would have to do. My party people, does that make sense before I show you the other way of doing this one? Right on. Right on. So let's go ahead here and let me show you the other way of doing this. I am going to take what we originally had, because this is on the previous slide, and I'm going to make all of that disappear. So let's go ahead, get you out of here, and let me show you how we would get this done the right way. Everybody, here we go. Let's rewrite the information. Percent times original equals the result. So the percent times the original equals the result. So everybody, the result that we want, what was it again? Was it the amount of the discount, or was it the final price after discount? Correct. We want the final price. We want that final price. Sometimes you don't need to go ahead and do one thing then another. Sometimes you can get your answer in one shot. And let me show you. So we want, again, the final price. So let me write this out here. We want the final price. And so if we want the final price, then we want to use the percent that represents the percent that we'll pay, the final percent. So we want to put in here the final percent. That's what we want to do. And let me show you what that looks like. Everybody hit me again, pop quiz. The original amount is represented by what percent? That's correct. That's going to be 100. I'm going to go ahead and this is the only reason why I left this down here. Let me show you this. This is how parallel it works. Like this is pretty fun. Let me get this out of the way. Oh, straighten that out there. Perfect. All right. Now we have 100%. That is our original percent. Then if we go ahead and subtract the 15%, again, everybody, the 15% was what again? It was that discount. It was that discount. And so everybody, when we subtract 15 from 100, what's that going to give us? 100 minus 15, that gives us 85%. So let me write that out right there. And so think about it. If you have the original amount, you take away what's discounted, well, what you get at the end, everybody, is going to be your final percent. This is how much you'll pay, but in the form of a percentage. And so, okay, we just did a quick subtraction. We have 85%. How's that going to help us? This will help us get the final answer, again, in one shot. Look at this. I'm going to plug in the 85% right here. I'm going to plug it in right there. 85% turns into 0.85 right there. We multiply by the original $80 and we'll get the final price. Because again, we're using the final percentage, so that'll give us the final price. And before we even do the math, what was the answer again, everybody? What was the final price answer again? Yeah, it was 68. I think we can all see that right there, nice and easy. So you know what the answer should be. So I'm either going to look really good as your teacher, or I'm going to look like, somebody who should be wearing a hat and making funny noises. Let's find out. So here we go. Risking my job. Let's find out. We have 80 multiplied by 0.85. And let's see what's up. 0 multiplied by 5, that's 0. 8 multiplied by 5, that's going to be 40. Okay, cool. So far, so good. Then up next, we're going to move over to the 8. So we'll just put a 0 here to move over. And so we have 0 multiplied by 8, that's going to be 0. 8 multiplied by 8, that's going to be 64. And so boom, once we have all that, we have 0 plus 0, 0 plus 0, 4 plus 4, 6 plus nothing. My party people, how many decimal places are we moving back now? Yeah, we're going to be moving 2 decimal places back. So we'll have 1, 2. We have none over here, but we have 2 over here. So that makes it 2. So we have 1, 2, making the final price $68. So help me out, everybody. Do I keep my job? Am I good? Am I keeping my job today? Yes, I am. Thankfully. And there we go. So hopefully, my party people, hopefully there's a group of us that are feeling more confident after seeing this, because I'm not expecting everybody to be perfect yet. We've only done 2 examples. It takes time. But here's the premise. Instead of, if you're trying to find that final price after the discount, instead of finding the amount of the discount and then subtracting it to get the final price, you really just have to go ahead and do it in one shot. You can go ahead and do it in one shot by doing this. Remembering that the percent you apply and the result that you get being the same thing. So if I want the final price after the discount, you can use the final percent after the discount. It's all about that main idea. The percent you apply is the result that you get. Who here is feeling, again, more confident than they were before the first example? Right on. And so to answer your question, Emma, so you're asking, hey, so it's 15%, but why do we do the 85%? Is the percentage now what we have to pay? And that's correct. Exactly, Emma. When we take a look at the question in this one, It's what is the final price after the discount. So we want to know what that percentage is after the discount. And so that's how we got that 0.85, because when we look right over here, yep, that's exactly what happened. We had the original percentage, we take away that discount, and this represents the final percentage that we pay. Boom. And there we are. Let me bring that back there. And so the 12 came from the previous example. It's the same exact example, except one asks you for just the amount of the discount, and this one asks for the final price after the discount. And yeah, Louis, hey, Louis, you're not being annoying. So, yep, the original percentage is always going to be 100. Tax or discount, the original percentage is always 100. So with that, I want to give y'all a couple of moments here to take a screenshot, and then we're going to be moving over to our first example with tax. So go ahead, take a moment here, and we're moving forward. So let's take it over here to our first example regarding tax. So this one says, what is the amount of tax added to the price? Again, we are going to go straight to the question sentence. We're not going to start with the first sentence, start to finish. We're not trying to give ourselves anxiety. What we really want to do is understand the goal. Because once you know what the goal is, then you can worry about the numbers. So the goal right here, the who, what, when, where, why, how many, which of the following, that's where it's going to be found. So right here, we see that it says, what is the amount of tax added to the price? My party people, are we clear on that? We are not looking for the final price here. We are just looking for the amount of the tax. My party people, can we confirm or deny that before we move forward? Good. I want everybody let me know. Good. Correct. We want the amount of tax. So blank dollars of tax specifically. Again, it does not say the final price. It says tax. So if we want the amount of the tax, what percent are we going to multiply by? If we want the amount of the tax, what does the percent have to represent? I'm not asking you for the number of the percent. I'm asking you for what the percent is going to represent. If we want the amount of tax, then the percent we multiply represents what again? It represents the tax. Thank you, Jaslyn. Again, the percent you apply is the result that you get. Let's write this out here. Look, the percent that we apply is the result that we get. So here we are right there. So if we want the dollar amount of the tax, then we need to plug in the percent of the tax. No, you guys are good. You're going to make mistakes. Again, it's going to happen. I'm here to continue guiding you in that right direction. So that's what I meant when I said, don't be afraid to try your best. Mistakes are going to happen, but just keep that open mind on understanding the why, and we're good. So is anybody here seeing this a little better before I continue? Again, the percent and the result represent the same thing. You have to make sure they represent the same thing. Perfect. So if we're looking for that strictly the amount of tax, well, everybody, do they give us the percentage of the tax in here? A jacket is priced at $150 before tax. And then if an 8% sales tax is applied, what is the amount of tax added to the price? So yeah, in this case, yeah, right on. We're looking to use 8% tax over here, right here. 8% sales tax is what's going to be applied. So it's an 8% tax multiplied by the original amount of $150. And that's what's going to give us our answer. Everybody remind me again, pop quiz, how many times am I moving that decimal place on the 8%? Yeah, always twice. Because remember, that's dividing by 100. always twice. So there we are. Let's go ahead and zoom on in. Moving over once, twice. So that's going to be 0.08. So let's go ahead and write that down. We'll have 0.08 multiplied by 150. And that's what's going to give me the amount of the tax. So let's write this down, finish it up, and feel good. 150 multiplied by 0.08. So here we are, 0 times 8, that'll be 0. Then we have 5 times 8, that'll end up being 40, carry the 4. Then we have 1 times 8, that'll be 8, carry the 4, and that'll give us 12. So when we bring back those decimals, we have none up top, but we have 2 in the bottom here. So we have 2 decimal places that we're bringing back, 1 and 2, and there we go. $12 is the amount of the tax. And that's it. And we're good. Again, we always want to base our setup. We want to base it off of what we're looking for. So if we're looking for the amount of tax, well, then let's just go ahead and apply the percentage of the tax. And once you calculate, boom, you're done and you're all good. Our answer here is 12. I mean, it can feel like a lot for tax for sure, but the more, the higher the original price, the more tax you'll pay, right? Isaiah, why do you feel like tax is easier than discount? Well, I'm going to be real with you. It probably is. It probably is. Because you can do them the same exact way. Like with percentage discounts to find the final price, you can calculate the discount and then subtract it. Or you can go ahead and just apply the percentage discount on the 100% and then do your thing. But when we take a look at this next question, everybody, look, we're about to do the same exact situation. We're about to do the same exact situation, but a different question. And I want y'all to tell me what we're supposed to do. So in this problem, we see that it says $150 before tax, 8% tax is applied. What's the amount of the tax? In this next one, $150 before tax, 8% sales tax, but we're asking, what is the final price? My party people, different question, right? Can we confirm that? Different question, same situation, different question. Right on. Now, if we are looking for the final price, let's suppose we did the 8% accidentally. Let's suppose we did the 8% multiplied by the 150 and we got the $12 and that was the $12 tax. If we got that, what are we supposed to do with that $12 tax to get the final answer? What do we do that? Yeah, exactly. To get the final price, all we've got to do, my party people, is add the tax back to the original price. Add it back to the original price. So what that would look like is we have $150. That's the original. We're adding on top of that a $12 tax. Again, remember, taxes we add, not subtract. If you subtract trying to pay taxes, you will go to jail. So with that, we add that together and we get 162. And that is the final payment. That is the final pay. So my party people, does that make sense in terms of, again, if you're just trying to find that final price when tax is applied, just figure out what that tax amount is, add it back and you're good. The only reason I'm really promoting this as the primary method, only reason, is because when you try to do this with the actual percentages, you can still do it. It's just gonna be a little weird. Here's what I mean. We have 100%. That's the original. Then we have the 8%. That is the tax. If we add those together, we end up getting 108%, and that is the final pay. So if we're trying to do 108%, because that does represent the result we want the final payment. If we try to do that, it'll just be a little weird. So Junzi, it will work. It will work if we do it. Watch. It will work if we do 108% times 150. But here's why I'm saying it's going to be a little weird. Here's why I'm saying that. So let me just kind of block this off here. And let me take this. And let me just move this slightly out of the way. Now, everybody, here's what the little issue is going to be. If I move the decimal place over, 1, 2, again, always twice, we have 1.08 times 150. Again, still doable, still very doable. However, is anybody here the kind of sicko that likes to multiply by 3-digit numbers? Is anybody here that kind of person? Anybody? Any takers? Did I see a yes? You need to get out right now. Who was that? Ariane? Yeah, no. Nah. No, I can't imagine anybody here taking a standardized test wanting to multiply a 3-digit number by another 3-digit number. That's all I'm saying. Will this still get you the same correct answer? Absolutely. Let me grab my calculator right here. I'm going to grab my calculator and I'm going to go ahead and do 150 multiplied by 1.08 and boom, I get 162. I get the same correct answer. Same correct answer. But when you think about which method is going to be faster, everybody, think about it. What's going to be faster? Multiplying by 1 digit over here, 8% times 150, multiplying by a 1-digit number, and then just adding it back, or multiplying a 3-digit number by a 3-digit number, right? What's faster? And that's the reason that we have to approach this with. We just have to be reasonable, or in other words, work smarter, not harder. Exactly. So who here understands where I'm coming from? You know, adding the percentage to 100%, it still works. It still absolutely works. But in the context of taking a test like the one that we're preparing for, we're not trying to waste that kind of time. That's all it is. Now, if we were allowed to use a calculator on this section, that'd be great. That'd be great. So with that, I do want to give you the chance to take a screenshot here because we do have enough time for at least, we do have enough time for at least 2 to 4 questions before the class ends. So if you're ready to move forward to some timed practice, feel free to go ahead and type ready in the chat box. Right on. And let me go ahead and get the problem prepared for you. And yep. So let's check out this question. So remember, the first thing we always want to do is read the question, RTQ. So what are we asking for, everybody? Give me a word or a phrase. What are we looking for when it says, what is the final price he pays for the shoes? What are we looking for? Yeah, that's right. One way to say it is we're looking for the final price. Final price. So when we think about everything we see here, everybody, you know, what's the information that we see? Well, I'm going to spot it here. It says the pair of shoes originally cost $60. And I also see that there's a 20% discount on those shoes. My party people, this is how you can tell whether or not you're on the right track. Watch this. I'm going to write this 20% times the original $60. If I were to just write this out, everybody, what is this number going to represent? I don't care what number it actually is. Don't tell me 12, 24, whatever. Don't tell me any of that. I don't care about that. What is this going to represent? What is that going to represent? Yeah, I know it's going to be the result. I know the formula says that this is where the result belongs. But what is this going to represent? Yes, it is going to be the discount. It is going to represent the discount. How do I know that, everybody? Well, tell me, what does this represent over here? What does the 20% represent? Yeah, it's the discount. It's right there. That is the percent of the discount. And so therefore, everybody, because the percent that you apply and the result that you get, they represent the same thing. Because of that, these both represent the discount if you were to set it up like this. Why is that a problem? Well, everybody, are we being asked to find the amount of the discount? No, we're not. That's right. We are not asked to find that. We want the final price. So if we wanted the final price, we would want to plug in the final percent if we wanted to get the correct answer immediately. But let's just suppose that we did the 20% anyway, just to show you what's up. So we would have 0.2, because again, move it over twice. We can get rid of that last zero there. So 0.2 multiplied by 60. Let me show you that right here. 60 multiplied by 0.2. So we have 0 multiplied by 2, and that'll be 0. Then we have 6 multiplied by 2, and that'll be 12. How many decimal places do we bring back? None here, 1 there. Just 1 decimal place that we'll bring back, and that is a $12 discount. That's not the answer A. That's not the answer because, again, we wanted the final price. So because of that, all we would need to do if we did that was take the original $60, subtract the $12 of the discount, and that'll give us the final price. So 60 minus 12 would give us 48 in this case. That's the final. Now, my party people, with that said, if we wanted to do this in one shot, not one, then 2 steps, if we wanted to get this done in 1 step, well, this is how we would do it. If we wanted to do that, let me get this over here and make it a little smaller. All right. Now, if we wanted the final price, we want the final percent. And the final percent would be the original 100% minus the 20% discount, and that would be 80%. That's the final percentage. So what we would have is right over here. So this right here would turn into 80% times the $60, and that'll give us the final price. Who here sees where I'm going with this? Who sees, yeah, this is actually starting to make a lot of sense, and I see how to manipulate this. I see how to rework this. Perfect. The next lesson, oh man, I can't wait to do all straight up practice problems. This is going to be so much fun. Here we go. So let me zoom on in and just do the same math so I can show you the right answer. So here we are. We have 60 multiplied by, move it over twice. So that'll be 0.8. 0 times 8, 6 times 8 is 48. Bring 1 decimal place back, and there you go. Final price, $48, and you get it in 1 shot, not 2 shots over here. That's what it's all about, everybody. Being able to work the same problem that everybody else is doing, but in the most optimal fashion to save as much time. So with that said, my party people, are we ready for the next one? We ready to try one more out? Right on, let's go. So with that, let's move it over here. In this problem here, we are looking for the amount of tax that we're gonna pay. So remember, reading that question first, it's gonna help you make the determination fairly quickly, at least compared to if you were gonna read everything start to finish and then, have to go through the questions and the confusion. No, it's actually a lot better if we go straight to the question. What is the amount of tax that he will pay? Boom. We are specifically looking for the amount of tax. So everybody, if we are looking for the amount of the tax, we are supposed to be applying the percent of the tax. That's the consistency that you want to go with here. So again, if we're looking for the amount of tax, we want to apply the percent tax, and that is 8% tax. Multiply that by the original price of $500, and we are good to go. Because if we apply the percentage tax, we will get the amount of tax. And that's what it's all about, everybody. So here we go. Let's do the math here. Now remember, we want to turn that percent into a decimal. And when we do that, everybody, you've got to be careful. We have 2 decimal places moved over. So this will be 0.08. If you wrote 0.8, these are not the same thing. These are not. Remember that I said you can eliminate trailing zeros, not zeros in the middle. No, that's not how that works. It's only trailing zeros at the end that you can remove. So this is still going to be 0.08. Do we understand that before I continue? I know a couple of us may have made that mistake, and I do want to make sure I always reinforce that for sure. I got you. So we have 0.08 multiplied by the 500, and that's going to equal the amount of tax. So as we multiply here with this one, we have 500 multiplied by 0.08. Okay, here we go. 0 times 8, 0 times 8, and 5 times 8, that's going to be 40. We bring back none up top, but then we have 1, 2 on the bottom. 1, 2, and there we go. The amount of the tax is $40. And there we are. All set, all good, and we can keep it moving. And that's answer choice B. And there we are. So with that said, who here is feeling confident after going through that introduction to taxes and discounts? Who's feeling pretty good about that? Because, obviously we can adjust the numbers, we can adjust the situations, we can get everything going. So I'm really excited for y'all to come into tomorrow's class, the follow-up session, that's going to allow you to look at problems that maybe not everything is discounted or not everything is taxed, and you have multiple items. What are you going to do when you have situations like this? I know some of us might be looking at this saying, oh God, no, coach, why'd you show that to me? No, you're good. We're going to take it one step at a time, and I'm going to show you exactly how we can do problems like this too. It always just takes the same learning principle. We're here to get one day better, one day at a time. Remember your rules. The percent that you apply is the result that you get. And as long as you are always thinking of that with your formula, practicing with your notes, tomorrow's class, the next lesson after this, is going to be so much easier than you think it actually is. I know it looks tough at first, just like it might have looked tough in the beginning here today, but we worked our butts off and we're here in a better place. And that's what really makes me excited for tomorrow's class with those tougher questions.